We all know that when you have physical access to a machine, that's game over. But how much game over are we talking, actually? Let's find out how completely defenseless Intel chipsets are when faced with USB. Here's Maxim Goriaki with Tapping into the Core. Let's give him a big round of applause.
Wow. Okay. My name is Maxim Goriaki. I am a security researcher at a Positive Technologies company. Unfortunately, my author couldn't be here. His contribution to the work huge, and please consider that we did his work together. So, I would like to cover the topic of hardware Trojan and tell about one of the modern Intel CPU design features that can be used for this purpose. It's direct connect interface. Okay. As you can see from the slide, we're going to review the debugging interface as a basis of such Trojan on the modern Intel CPU. We're going to review direct connect interface. It's JTAG-like interface and his activation. And then I'm going to talk about several tips that can you help to detect such attack. And so, a hardware Trojan is a malicious alternation of hardware that could, under specific condition, result in functional changes on to the system. It can be inserted at the time of manufacture, shipment, and storage or use. You can find information on this type and general technique of detection in the paper mentioned on the slide. I think there is no need to emphasize the timelines of this system attack vector. And in the NSA catalog, which recently became available to public, contains information on a dedicated device for Dell servers that in effect a classic hardware Trojan. And what I've just said logically raises the following question: how much would it cost to implement such a Trojan on modern systems? That is cost of the development and embedding such Trojans, and are those techniques available to people or organizations who are not state security services? Our reports will show that unfortunately yes, and implementing such Trojan may be possible for anywhere who is willing to exploit the possibilities provided JTAG on the modern CPUs. And oh, sorry. It's NSA. Let's step aside a bit, review the JTAG debugging technique a little closer and try to find it Intel CPUs. JTAG standards for joint test action group, and you can find as detail its description in IEEE with the detail available in the standards itself, how you can see a reference on the slide. There is also a video from CCC conference available on YouTube where the design is described in close detail. And but sometimes manufacturer, but generally, JTAG is good not only as a basis of Trojan. It can also be used for forensic. For example, if you don't trust the BIOS and would like to read firmware manually from SPI flash without a programmer, or to detect a rootkit, And JTAG can also be helpful in research for analyzing undocumented architecture technique, also as boot guard or system management mode. And it also may simplify debugging of hypervisor and drivers or power consumption or UEFI models and some way. Often manufacturers extend the standard JTAG by adding their own functionalities. And Intel do it too. JTAG in Intel processor is described rather poorly. Some information can be found in the documentation I mentioned on the slide. And how you can see, Intel CPU have 3 types of interface for JTAG. It's direct connection through Intel in-target probe extended debug port, ITP-XDP, and Intel, it's new technology, Intel Direct Connect interface. It's special transport designed to enable closed chases debug through any of USB 3 ports. You can use JTAG-like interface through USB 3. And there are 2 types of DCI hosting interface in the platform: USB 3 hosting DCI and BSSB hosting DCI. And now let's take a closer look at each of them. Intel ITP-XDP, it requires the special board and special socket, but it connects directly to the CPU, and it is capability with Intel System Studio. You can download a trial version from the manufacturer websites, and has protocol protected by NDA, and makes a lot noise and gets hot. Really. I check it. Starting with Skylake, Intel introduced direct connect interface technology, and you can find rather specific description of it in the documentation. The diagram shows 2 types of connection using a special device and simple USB 3 debug cable. Here, I would like to note that the target system is not this case does not require any software or hardware against. You need only cable or special device. Okay, and this technology, unfortunately, is works out of box only with U series chipsets. And let's take a closer look at each of connection type. Okay, BSSB hosting DCI. Its connection required special device. Intel Silicon View Technology Closed Chases Adapter, also known as SVT SCCA or BSSB, provides access to DFX feature and like JTAG and run control through USB 3 ports on Intel direct connect interface enabled silicon and platforms. It works through USB through links, but implements a private protocol and makes it possible to manipulate the target system in deep sleep mode. Unfortunately, as of months ago, both XDP and SVT adapters may be able only after signing NDA with Intel. But it's not a problem. Because we have special device. USB 3 hosting DCI is a common USB 3 debug cable which works as an OTG device. That means that special device appears on the host system and activation. It's really true. It's device. It's motherboard. And commands are sent to this device through a common USB interface. The device itself is integrated into platform control hub and it transforms the command into JTAG. And it's JTAG for purs. And small demo. One moment. We select a configuration, wait for connection to target platform, and stop execution on the old thread. From this device. Current instruction. Special MSR. And I'm sorry. That's okay. One step. Okay. It's work. Okay. Demo is end. How to activate this magic function? There are several ways to do that. Through UEFI human interface infrastructure, PCH strap, and special hidden P2USB device. Now let's review each of them in detail. Activation via UEFI human interface infrastructure. UEFI human interface infrastructure is a special interface that allows creating a user form in UEFI, as well as processing and manipulating user input. If we look at how the modern UEFI BIOS designed, we can find a lot of hidden options that are not available to the user, but processed by BIOS. There is, in fact, the basis of our first technique. UEFI human interface infrastructure identifies default values for all options, including the hidden ones. And as soon as we find the option connected to DCI, it can be activated to set defaults. DCI enable special hidden option. UEFI defines default value, full option, and we find the option connected with DCI. It can be activated to set defaults, then resetting the BIOS to default using standard interface, and we obtain a working DCI. It's easy. The edited image is programmed into SPI flash by a programmer or through the standard BIOS firmware tool if you have privileges. You can those settings can be edited by a special AMI BIOS configuration program on the slide. Is it? It's free. You can download from AMI website. And if bootguard is running, this technique don't work because the system will not boot since this tool changes the UEFI model. But you can activation via PCH trap. DCI can also be activated by configuration specific bit on the PCH configuration, either manually. They are located in flash descriptor region, or by using flash image tool. It is special tool for create firmware BIOS. This technique works even if bootguard is activated. It's good. And finally, you can try to activate it directly through P2USB device. You can find a special index and register in documents for different PCH generation. Right, it's 6 generation, and left from 7 generation. And use those data for DCI activation on the fly if BIOS has not blocked DCI setting changes. Okay, right? We know some motherboard where it's work. And that leads to the question, how can we protect ourselves from such Trojans? We propose activating bootguard in order to make the modification descripted in the first. Then you can check the DCI enable bit and debugging disabling register through special debug interface MSR. In this case, DCI may be enabled, but execution cannot be stopped. As a result, it's impossible to get access to memory and register. And you can see documentation. The least significant bit this register makes it possible to restrict CPU debugging. So we need to set to 0 and lock the register itself, recording bit 1 into special field. And can you help to protect your platform, your laptops, and new age of BTUSB? You can find or make special device which transmits commands from USB or Wi-Fi and use it to implemented backdoor in servers, in laptop or servers or another motherboards or computer. And Modern the CPUs allows using debugging tools which they help to USB 3 available to numerous platforms. These tools make it possible to control a system totally, making the technology attractive not only for debugging and research, but also for deploying hardware Trojan. And please check your Skylake laptops. And thank you for your attention. And maybe we publish special tool on GitHub of our company, which can help you to check your motherboard. Thank you for your attention.
Spasibo, Maxim. So, questions. Do we have any questions for Maxim about JTAG over USB? I see one already here in the front.
Thanks for a great talk. Two questions. First of all, could you share which motherboards allow enabling such debugging features?
We know only one vendors because, but we don't search in other vendors, and we don't know how much these vendors why available to use this functionality.
Second question: is it possible to send debugging data not via USB, but via network itself?
Why not? You have management engine processor.
Scary, thanks.
Okay, we have a question from the internet.
Hello? Okay. The internet wants to know if you have tried reverse engineering the protocol the USB box uses.
Yeah. But it's next series.
Here in the front.
So have you contacted Intel, and if yes, what they said?
Yes, they don't set anything.
In the back by the camera?
So the debugging features can be disabled by the BIOS, right?
Sorry, what?
The debugging features can be disabled depending on your vendor by the BIOS, right?
DCI? Unfortunately, sometimes no, because you can because configuration of DCI is enabling to PCH strap, and if in PCH strap on platform hub is activated, BIOS can't disable it. And if you have DCI, you always enable any features because you can stop on the reset vector. Sorry.
Okay, so any idea how widespread this is?
The question was, do you have any idea how widespread this problem is?
I don't know. Maybe I think that Intel implemented special technique which connection with cryptography, but don't use it now. And I think that maybe in next generation he activated it.
We have another question from the internet.
Yep. The internet wants to know if it's possible to use this to do something to bypass some kind of signature check or something. So if you can like modify what's being executed, basically.
No, because PCH strap is not signatory. and you can rewrite it for BIOS, and boot guard on another technology don't see it.
Okay. Is there a follow-up question from the internet?
Yeah, there's a different question. That is, people want to know if and where they can get your slides and read more about your research.
Sorry, repeat the question.
They want to know if and where they can get the slides and read more about your research.
In my email. Okay, write me. I asked about. I tell about it.
Okay, in the back.
Yeah, thanks for the talk. Did you do any research on platforms prior to Skylake? Let's say Haswell or something like that?
Haswell has same technique, but unfortunately DCI it's hardware technique. In Haswell it's software technique, and sometimes I didn't see special firmware which can use this JTAG-like interface. Its technology, SVT adapter, works from Haswell, but only after signing NDA.
So Haswell doesn't work with a simple USB device?
No. Only Skylake. Only Skylake.
Thanks.
Okay. In the EFF shirt.
Are you familiar with antivirus products that also use the Intel debug states, like Checkpoint, Sandblast, for example? And how is this similar, or does it interfere with the hardware?
It's difficult because it's very non-stable works.
So does that technique interfere? Like, would the Checkpoint Sandblast detect this, or?
The Checkpoint, it's maybe because this technique have some troubles. For example, it use hardware register, and you can read addresses, and you can read modify of memory which doing this SVT or USB JTAG-like device, and it's detect for malicious for virus, and maybe you can use it, but not good sometimes.
Okay, we have time for about 3 more. Did you have a follow-up? No? Okay, then in the front.
Is it tracing capabilities possible to, well, is it possible to trace code and maybe read memory?
Yes.
While core is in SMM mode?
Yes.
Okay, so you can read all the SMM procedures, and you can take the vectors. Can you use this technique to write SMM vectors?
You can use hardware breakpoint for special register on the right. Insert this breakpoint and don't able to lock the memory which use to system management mode, for example, and read it. We're doing it. Yeah.
Okay, in the back right.
So the protocol, as you said, is protected under NDA. Are you aware of any open research on this topic?
Yes, it's open research.
Okay. Another thing, is it like following the normal USB protocol, or do you really need some special electric properties?
For SVT special adapter, it's property protocol which using the signal of USB 3, but it's not USB 3. And this cable, it's simple USB 3 protocol, And yes, you can write program which, for example, can trace your target system. Yeah.
Okay, and last one in the back.
Is it like JTAG compatible in such a way that it has a scan chain and stuff, or is this some Intel invention, this DCI protocol?
DCI, I know. I think that DCI is a special device which retranslated the commands from USB to JTAG chain, JTAG tabs. Yeah, right?
So it's like toggling the JTAG signals?
Yeah, yes.
So that's what happens. Wow. And is there any chance to put this support into OpenOCD or such open source software?
Maybe in the future.
Thanks.
Okay, let's put our hands together for Maxime one more time.